Okay, Team Impact. I doubt you're watching this in class, but if you're at home watching this, take a look at it. You can kind of set up here in the command center. Today we're going to be talking about some expressions, some new vocabulary. Um, so let's get into this. When we talk about expressions, we're going to be talking about coefficients, variables, constants, things like that. We're going to define all of these terms within this packet and then in the homework. We also reviewed order of operations in class pretty good extensively. So if you missed out, sorry about that. Okay. So when we look at this, it says substitute the values of each fruit to determine the total amount of fruit harvested. Okay. Well, this is pretty quick, and what we're trying to do is just substitute here. So I see it looks like an apple is 13, and I see a pear, and it looks like 14, and cherries are 30, right? So when we look at all of that, that's what we're looking at when we're talking about variables. We're substituting a number for the variable, and a variable can be any letter in the alphabet. In this case, they're using fruit, okay? So when we look at this, all right, it says rewrite the expression in letters A, P, and C to represent it. So it would be A plus P plus C, right? Variables represent the fruit. An expression is a mathematical phrase that contains numbers, right? Numbers, variables, and operations, right? A variable, right, is used in mathematical expressions to represent an unknown numerical value. So a variable can be any letter in the alphabet as long as it's lowercase. So what we're going to do here is break this down a little bit. We're going to define what we have here, okay? All right, so let's first off talk about this 4. The number before the variable, and this is read 4D, is called a coefficient. Efficient. Coefficient. We've talked a little bit about this in before, but that just tells me how many D's I have. 4 D's, right? The letter's the variable, right? Now, when we put the variable and the coefficient together, when we put these together, this is called a term. A term, right? This is, our 9 is constant. Constant means it does not waver. The only way we can change the 9 is add, subtract, multiply, or divide to it. But 9 is 9. It is constant, right? Conversely, against a variable, right, it varies. And that, of course, is our operation, right? Our operation. So when we look at this and we read it, it's read as 4D minus 9. And what we're going to do right now is we're going to substitute numbers for the variables, and then we're going to perform operations, okay? And then later we're going to be combining variables. That's when it gets a lot of fun. This, still pretty easy stuff. We're early in the unit. So x is 7. 7 plus the quantity of y plus 2, right? Then we go back to our order of operations. 7 plus 5 is 12. Okay. So over here, z is 2 times the quantity of x, which is 7, plus y minus, plus y. Got a substitute there. How about plus 3 minus 2? Minus 2, okay? Let's follow the order of operations again. 14 plus 3 minus 2. 17 minus 2 is the 15. And circle your final answer. So again, I should be underlining those operations that I'm doing. Sometimes I go just too fast, okay? Next up is number 3, y squared minus z squared. So y is 3, It's 3 square minus z, which is 2 square. So let's perform both of those and then we'll subtract, right? Please excuse my dear Aunt Sally. 3 square is 9 minus 2 square is 4, which is 5. Okay. Moving on to the next one, just trying to give you a pause there so you can 7x plus 5y plus 3. So we have a good expression here. And we're going to substitute x with 8 and y with 6. So 7 times 8 plus 5 times 6 plus 3. Okay, let me pull that up just a little bit for you. We can go ahead and do our multiplication first, right? Separated by an addition sign. So this is 56 plus 5 times 6 is 30 plus 3. Now, the commutative property says I can add in any order I want, but it's easiest just to go left to right here, right? 56 plus 30 is 86 plus 3 is 89. So math is starting to get fun here, right? We're getting out of the stuff that we always did and into some new material, which is always good, right? List all parts of the expression in example 4. Okay? Okay. So here's our expression. This is what we want to focus on right here. So we're looking for the terms. So if we go back to our terms, all right, let's talk about this. Well, 7x is a term, right? 5y is a term, but guess what? So is 3. Terms are all pieces in the expression, okay? Our variables are just x and y. They're just our letters, right? And then our coefficients of the variables, the numbers in front of the letter, is 7 and 5. And then finally, the thing that never changes is the 3. It is constant. Constant. Okay, so I'll make sure you get a chance to get caught up there. Okay, so some good stuff so far. Let's flip the page and take a look at what we have on the next page. Evaluating expressions is commonly used when substituting values into formulas to solve real-world problems. Use the formulas to complete the tables by showing below by evaluating the expression. All right, so they're going to give us some formulas here. Okay, we've talked about these formulas. To find the area of the rectangle is base times height. Area is base times height. So area is going to equal 2 7/10 times 6. And you'll notice I'm using an X here. Sometimes I use a dot, and other times I'll use parentheses. I just interchange it, right? And then if we take 6 times 2, well, 6 times 7 is 42, carry the 4. 12 and 4 is 16, 1 to the right. And we have to label this now, okay? And it's going to be labeled centimeters square. Area is always in square units, always. Okay? Next up is our square. Now, ideally, we could use this same formula for the square, but they're giving us a different one, which is just a side to the second power, because a square has 4 equal sides. So area is going to equal 11 square. And 11 square is 11 times 11. And 11 times 11 through our facts is 121. And it's also in centimeters square. Okay. All right. Let's press and pause here just for a second. Okay. I'll let you get caught up and let that process for a minute. Okay. All right. Next up, okay, is another rectangle, it looks like. Darius is building a fence around his rectangular butterfly garden. The length and the width of his garden are shown. Use the formula of perimeter. P equals 2L plus 2W to find the total distance around. So 2L plus 2W. So P equals 2L plus 2W, right? And that will give us the distance around. We have been adding them up, but there's a simple formula for this. So it's 2 times 8.3 plus 2 times 4, right? And you would do both of these operations and then add it, okay? So this is an easy one. That's 8. 2 times 3 is 6, decimal. 2 times 8 is 16. And when you add them up, you get a sum now, all right? A sum of 24 and 6/10 feet. It is not area, it is perimeter. So that's the linear. That's walking around, linear feet. Up here, our area is blocks. How many 1 by 1 by 1 by 1 centimeters could fit in there? And that's what that means, okay? Number 7. Two squares are shown. Evaluate b squared minus c squared to find the difference between the areas. Okay. Well, b is that, so we're going to evaluate b squared minus c squared. b is 12 square minus c is 5 square. And our multiplication facts say 12 12s are 144 minus 25, right? I took care of those two. I'm going to take care of that. I'm going to end up with 119. Now, how do we label this, right? So what is the difference between areas? The areas, so it's 120 centimeters square. Has to be labeled anytime area is in square units, okay? All right, excellent. Let's continue on. Renee made an error as she evaluated 4x minus y squared when x is 10 and y is 2. Determine her area, her error, and then completely evaluate the expression. All right, well, let's write down 4x, right, plus y squared. I always like to work it out, and then I can compare and contrast. I have trouble sometimes figuring that out. First off, they didn't substitute correctly, so 4x. So what do we got here? X is 10, so it's 4 times 10 plus y is 2 squared. So 4 times 10 is 40 plus 2 times 2 is 4, right? And clearly you can see the mistake was right there. They said 4 times 10 is 410. No, it's 44, right? And do we have something here determined, right? She evaluated the expression. So we just have an answer of 44. It's not area, it's not perimeter. I saw that box and I thought it might be. So our final answer is just 44, not 14. Right here's the issue. Okay. Okay. So if you flip to the next page, you're going to be doing a lot of the same. You're going to be substituting and doing it. Take your time. Make sure that you're substituting. I do not want it done mentally. I want it written down. Find your letters and then come up with what do variables ask each other when they meet. Have a good day.